Okay, now the last section in this three-part series will be power. There's not much really we can speak about when it comes to power, but what it means, it is the rate at which energy is transferred, which is why power is given by the formula of work over time, or power is given by force multiplied by velocity. Okay? The SI unit for power is measured in the watts, which means work per meter per second, or work per second. Okay, the best way for you to learn, I think you've understood from watching these videos, is about solving problems. Let's look at this activity here. A motor car of mass 40 kg moves at a constant speed up a slope that makes an angle of 10 degrees with the horizontal. The motor car experiences a frictional force as it moves up the slope. Draw a free body diagram that indicates the forces acting on the car. Okay. What I normally like to do, on the side here, I'll draw a triangle to show my 10 degrees. That's the box. Motor car is moving that way. The engine obviously is force applied, right? This is the frictional force. Then directly with that horizontal, there will be F normal. Then down like that, there will be Fg, right? But moving up with the car will be F parallel. So you come here, do a dot, that will be Fn, that will be F applied, that will be frictional force, and that will be Fg. And then you just label. F1 will be normal force, FAPP force engine, FF is frictional, and Fg is your weight. Happy? Great stuff. Okay. Second question. Calculate the applied force necessary to move the car up the slope at a constant velocity. Now, when they say constant velocity, this means that there was no acceleration, correct? Now, it is important for you to remember when they say constant speed, they mean that there is no acceleration, right? So we know that F net is equal to mass times acceleration, Newton's second law. So F net will equal our mass of 1,400 kgs times 0, which will give us 0 newtons. So the total applied force is 0 newtons. Now come here, write a different formula. F net. Now you're going to list all the forces. We have F applied, right? We have frictional force, and we have F parallel, right? So we're going to say 0 equals F applied, which is what we're looking for, plus frictional force is acting in the opposite direction. They gave it to us as 700, remember? And then F parallel will be our weight, which is 1,400 times 9,8 times the sine of 10 degrees. I'm sure I don't need to explain this to you. Then we're just going to tidy everything up here. We're going to say 1,400 multiplied by 9,8 multiplied by the sine of 10 is that minus 700, which is that. Then we know that F applied plus 1,682.46. Okay. I made a mistake here. Sorry. No, man. F parallel, the only positive force will be, I made a mistake here. Let me try this again. F net will equal force applied minus frictional force minus F parallel, because the car is moving up. So F parallel will be working against the car because of the weight of the car. Remember, gravity will work against you when you are moving up. So 0 is equals to F applied minus 700 minus what we just wrote of 1,400 multiplied by 9,8 multiplied by the sine of 10, which is negative 700 minus 1,400 times 9,8 times the sine of 10, which will give us F applied minus 3,082.45, which makes F applied to equal to 3,082.45 newtons moving up. So that is how much force we needed to move up the slope. Okay? Perfect. Perfect. Now, if the motor car moves at 80 kilometers an hour, calculate the power delivered by the motor car's engine. Now, remember, we're gonna do this. We're gonna say F applied is equals to 3,802,45, right? Then I just wanna erase all of this. Now, we could calculate work, right? We could use this force. Remember, power has two formulas. Power is equals to work over time, but power is also equals to force times velocity. Now, the velocity they gave us was 80 kilometers per hour, right? Remember, to convert that, you need to divide that by 3,6 to get it to meters per second, which gives us 22,22 meters per second. Now we can say that power is equals to force times velocity. Force being 3,802,45 multiplied by 22,22, which will give us 68,498.89 watts. Okay, so moving forward now, we're gonna do another video. It's gonna drop tomorrow of question papers, and now we're gonna try and tackle a question paper that is gonna require us to use all of this knowledge together.